In this video, I will guide you through a problem in Smith's Organic Chemistry. I'm Stoddard, founder of Study Chem, the place for students to turn for higher grades in OChem. Let's get started. This problem here says simply draw the products of each reaction. You want to do a couple things here. First, for your epoxide, you want to carefully determine which is more substituted and which is less substituted. This carbon's secondary, this carbon's primary. So the primary is less substituted and the secondary is more substituted. You want to think about the reagents. Are they acidic or basic? HBr is an acid, this is acidic. What that means is that the bromine attaches to the more substituted carbon and we invert this stereogenic center. Okay, we're going to invert here. Inversion is going to occur. So let's go ahead and try to draw this organic molecule out. We've got the six-membered ring. The primary carbon down below remains the same. It's going to be on a wedge, and we're going to write OH. Now, attached to this carbon here, we have a methyl group and a bromine. The bromine is going to be on the opposite side as the oxygen. Oxygen's on a wedge here, so we want to write dash to the bromine. And we want to flip this wedged methyl group to this dashed methyl group to a wedge methyl group. All right. In our next problem here, we want to think about, once again, which one's more substituted, which one's less substituted. Here we have basic reaction conditions, which means that the nucleophile is going to attack the less substituted carbon. So in this case, we're going to get an organic molecule where the cyano group is connected to the bottom carbon, and we want to attach that from the opposite face. So this methyl group, this cyano group is going to be on a dash. The other carbon atom is not going to undergo inversion, so we indicate those groups as shown here. All right. Here again, you want to look to see what's more substituted. This carbon's more substituted. And we have acid conditions. This is a neutral alcohol, but if you look under the arrow, we have H2SO4, which is acidic. So we want to attach this whole group here, this ethyl oxy group, or this ethanol group, to this arrowed carbon. It's going to come in from this side of the molecule and kick out the oxygen. So the product here is going to look like this. Okay, the oxygen is going to get kicked up over here. And I'm going to go ahead and just draw these hydrogens in. Okay, and down to the bottom left, we have this ethoxy group. Okay, the CH3, CH2O. And I'm going to go ahead and use my wedges and dashes here, and I'll have those ethyl groups over here. So CH3, CH2, and another ethyl group up here. Okay, so this group is going to attach to the more substituted carbon. Now down below things look similar, but actually it's a little bit different. Once again, we have the more substituted carbon here, but this is basic. Okay, alkoxides are basic, and what that means is that they're actually going to attack the less substituted carbon. So what we're going to get is a molecule that looks like this. Your OCH3 is going to be down here from the opposite face, and we have our two hydrogens here. Attached to this carbon here, we have the OH that used to be the oxygen from the epoxide, and we have our two ethyl groups over here. Okay. So just remember, acidic conditions will install your nucleophile on the more substituted carbon. basic reaction conditions will install your nucleophile on the less substituted carbon of your epoxide. In all cases, we invert that stereogenic center. Thanks for watching.